Thanks to everyone here participating. There's a lot of hype around robotics at the moment. There's a lot of hype around demos, and there's a reason why we are focusing on what's happening if you leave the demos behind you and you bring robotics to the actually customer and deploying. So this is the reason why we have people here who have experience with that, different kind of angles, different kind of products. We do have a Q&A afterwards, so if you guys stay a few minutes longer, let's see if we can pass around the microphone and ask a few questions. Other than that, thank you so much for coming, and I think we're good to go. All right. Yeah, you can applaud. First, I would like you to give you an opportunity to introduce yourself, because I think you guys have done a lot of pitches and you know exactly what to talk about you. And so please be so kind, and maybe you all of it could start.
Sure. I'm Oliver. I'm the CTO at Ultra. Ultra builds bimanual stationary robots to do specific tasks for warehouses. The first task that we're trying to solve is order packaging. So when you order something online, there's a very complicated warehouse process. Our robot sits at the very end of that and actually puts a shipping label on your order and sorts it out so your carrier can actually get it to you. We're very excited about robots in general, obviously. That's why we're working on it. And thank you, Alira, for having us here today.
Don't be shy.
Evan Beard, CEO of Standard Bots. We make robot arms and mobile base, and what's unique about us is we're training through demonstrations. So we've made a platform where it's starting with manufacturing and warehousing, but the average assembly worker can train a physical AI model, show the robot what to do, train the model, deploy it, and run physical AI in a factory. We make the hardware too, very vertically integrated in the design, and we're vertically integrated in the manufacture as well. So it's metal in and robots out, and yeah.
Pim de Witte, I built General Intuition, and we build foundation models for general agents for environments that require deep spatial temporal reasoning. So think of it as LLMs were trained on large-scale web data initially to start with, and we have a very, very large ground truth action data set. So instead of predicting the next text token, we predicted the next action token for spatial workloads over increasingly long horizons. Also, we are at the frontier of world models, since we use world models for RL for those agents.
Hi, I'm Josh Merrill. I was a co-founder of Fauna Robotics, which we started in early 2024. We build robots that operate everywhere people do. We started with a developer platform, which we launched in January. And so we've shipped to various customers so far, and we're still kind of scaling production and continuing to ship. About 2 months ago, we announced our acquisition by Amazon. So we're now still part of, we're still Fauna Robotics. We are part of Amazon as well. We're continuing to grow and accelerate the mission that we set out on as a startup. And yeah, just continuing that.
Yeah, thank you so much, everyone, for giving us a short intro. The way I would like to do it is asking questions, and not only me asking questions, you answering, but having some sort of a conversation. So I'm asking a question, and everyone can feel free to answer. And I have a few questions prepared for each and every one of you. One of the first questions that I do have is deployment, right? We were talking about demos and showing demos, and now everyone is picking up on that one, or leaving that one and picking up on deployments. So different people and different companies have different ideas of what deployment actually means. And maybe you can tell me a bit what you think is a deployment, right? This is open to everyone.
I'm happy to jump in and talk about what deployment means at Ultra. So we're selling solutions, not robots. So deployment for us, we have a very good idea going into a warehouse what we're actually trying to do, because we're starting, again, just with order packaging. The tricky part about deployment for us is learning the customer's process. Believe it or not, every packing station at every warehouse operates slightly differently. and integrating with the customer WMS. So our robot is pretty self-contained. I was at a customer site a couple weeks ago, and we had it out of the crate installed in 11 minutes. But the hard part is, again, integrating with the customer process. So we consider a robot to be fully deployed when we no longer have somebody on site, when it's just part of our normal remote support routine. And yeah, that's kind of the key, is that the customer is responsible for actually running the robot and getting output out of it. And we are kind of behind the scenes just making sure that the technology is running correctly.
I can go next. Or Standard Bots. I think we are America's largest industrial robot manufacturer right now. We're on track next year for 10% of industrial robot deployments in the United States. We've designed our product, and for those that don't know or haven't deployed manufacturing robots, you have a little bit of echo. You have to take courses often to deploy industrial robots, like often like a 2-week course, and even vision system can be multi-day course, and they start to write linear algebra on a chalkboard, and it's kind of insane. And so we've tried to make a product where you don't need a manual, like kind of like an iPhone. Like I don't even think there is a manual for an iPhone. And you can just pick it up and understand it, and it's intuitive. And so the way we aim to do deployments is make the product really simple, so we can just mail the box and the customer can take it out and install it and do it that way. So that's worked really well for us.
For us, it's we predict actions into the action space of the gamer, so the game controller or the keyboard and mouse. And so for us, the most common part of the deployment is actually figuring out whether the robot already ships with Windows systems, which usually it does, which means somebody has already built the interface for human input to precise sort of motor torque conversion. And so when that interface exists, the implementation is fairly easy because it just works off a single camera. Then it's understanding the workload related to how much you need sensors and forces. And I think for us right now, we primarily work on vision-based workloads, but understanding if any work needs to happen to account for any other degrees of freedom in the system, for example, is an important piece of the work. Usually that means understanding people's simulation environments and which data they already have to maybe bridge that gap, then getting to deployment very, very quickly, because you don't need to really touch the robot as much if you're already just predicting into the action space of the controller itself.
For us, deployment has been basically shipping to customers our developer kit. So we provide support for that as people use these devices and in some cases abuse them with like aggressive new policies that they want to try on the robot and things like that. They will break parts. And so deployment kind of begins with shipping the robot and people getting to use it, but then I think there's kind of a life cycle of deployment where you're basically expecting support. And I think there's some amount of support that we think about being included, and then there's of course some amount of support beyond the basics that people will likely need over time, like kind of a bicycle or a car. You're going to need tune-ups, and I think thinking about hardware in a kind of long-term way that way, so that it's not a disposable item, but something which you can keep using over a long period of time with fixes along the way, is how we kind of expect the ecosystem to evolve, and especially if you're going to use, do your own thing with the hardware that you purchase. So I think that's mostly our mental model for deployments at present.
Yeah, thank you so much. You were smiling, Oliver. Any thoughts?
Yeah, I mean, it's a good point about the life cycle of these, because it's not like an iPhone where you're going to upgrade every 2 years. Robots are pretty expensive these days, more like a car, right? You wouldn't buy a new car every 2 years, and I mean, you could. But there are maintenance networks, right? The point is that these things need to survive. And looking ahead to the future, I think there's going to be really a ton of demand for robots over the next 10, 50, 100 years. So building hardware to last, I think, makes a lot of sense, because there's a good chance that the systems you're building today could actually still be useful for quite a long time.
The way from a prototype to really having a system being deployed, where what you guys were all talking about, there's a huge journey, and you go through a lot of iterations. What was, and a few of you guys had been other companies before, right? So now talking about robotics, what was the biggest surprise, and do you have I have a story in mind. We were talking earlier today. I was visiting you guys. This is the reason why I bring this up, because you're surprised with, you spend so much time in the lab or in the simulation, and then you're building up the prototype to become a product, and then you bring the product and shipping the product, deploy the product. But on that journey, can you tell me funny stories, surprising stories about that journey?
You're really teeing me up here, so I will tell the story. Right after Ultra returned to New York, we were in San Francisco for a summer doing a Y Combinator batch. We found a design partner back here in New York. We moved across the street from them, and the first robot they wanted us to build was a sorting robot. Classic ML stack, find the box, go pick it, put it where it goes. We built it in the lab. We figured out our processes. Packages come down the conveyor belt, label up so we can read it. We spent 2 weeks testing the system. Everything was perfect. We took it over to the customer site. Literally the first package that the robot tried to pick, the suction gripper went down, grabbed the package, and just ripped the shipping label clean off. The box was still on the conveyor belt. We had the shipping label stuck to the suction gripper. Apparently, shipping labels take a while to actually stick to packages, and if you pull them up too hard, they'll just pop right off. We didn't see this in the lab because we had boxes that had been labeled 2, 3, 4 weeks ago. Who even knows? And there are lots of examples like that of things that you would just never think to check until you actually get to the customer site.
I mean, we learned lots from all of these tours where we take the robot out and try all of the capabilities we developed in different environments. And you learn a lot from this. We have a mapping stack which comes included with our robot, and building maps in many different places is interesting. We tested it obviously before we started selling it and shipping it, but getting to see all of the different specific customer locations was interesting. The one that I guess is maybe closer and easier to understand is we trained a policy using sim-to-real, using reinforcement learning to get the robot to get up from the ground when it's in a lie-down position. Depending on, it mostly worked across a bunch of different floor surfaces. One of the offices had extremely high friction textured carpet, and the robot moves in such a way when it gets up that actually interfered with it, and so that policy failed. And so that motivated us to go back to our office and buy a bunch of carpets and test out the policy as we do it on carpets that were more adversarial than we had.
One more, maybe it's not that funny, but for early deployments, there's a lot of industrial equipment that you have to integrate with. And so a lot of it's expensive, so we couldn't afford to buy it. So we would end up doing a lot of integrations on the customer site where we're writing the code to integrate with their CNC mills or laser marking machine or whatever it is, while there. So that was always fun.
So when you talk, we have different kind of companies here, different kind of products. And because hopefully we have a lot of people from the robotics community here, and we would like to maybe you can share a little bit without exposing too much, but from the different kind of problems that can happen, software, hardware, data can be a problem, customer can be a problem. Customer is always a problem. Maybe you guys can tell me, but what you think at the moment where we are as a community, not necessarily only with your own company, where do you see at the moment the biggest problem?
I think in simulation you can you sort of constrain a number of states, but in the real world the number of states is unknown, and so you can always run into sort of adverse events or things that are completely unexpected that the robot doesn't expect whatsoever, and then it's sometimes very difficult to recover from that. For us, we use a very, very large corpus of people playing video games in simulation, crashing cars, where the cost of doing that is really low. And so we train specifically, including lots of adverse events, for example. That's one of the ways to, for instance, we're able to avoid people on the sidewalk more easily when it happens unexpectedly.
Yeah. So I think as of a few years ago, there were not actually that many embodied ML solutions that were deployed anywhere, right? If you think about the spectrum of how consequential and from a safety criticality standpoint a model is, you can think about something like hand tracking for VR on the kind of low stakes version, where if there's a failure, it's not that big of a deal, right? Like the hands lose tracking of your physical hands, but from a VR interaction standpoint, it's not going to hurt you in all likelihood or anything like that. You could think of self-driving cars as being kind of on the far end of the spectrum. And you could think of robots generally as needing to operate with extremely high levels of reliability. So I think most people today, and this is different than even maybe 4 or 5 years ago, possibly even like as few as 3 years ago, people kind of take it for granted that robotics is going to be solved using learning-based approaches. Like it sounds crazy to think otherwise now, but for a long time, people thought that you would do other things like design controllers for locomotion or for stair climbing or things like that. And now learning-based approaches are dominant. But what that means is that the amount of testing and coverage you need to have to make sure that the learned policy or learned behavior is going to be safe is quite extreme, because it requires high reliability and coverage over many different use cases. And I think for things that are physical, where there's actions involved in the environment, robotics, self-driving cars, things of that nature, it's high stakes, that it matters a lot. And again, in a way that maybe is a little bit less true for things that were deployed first, so like computer vision models or kind of body tracking models that you could use in a way that, even if it was closed loop, it was still sort of semi-closed loop, and you could get away with it not having adverse outcomes physically.
Yeah. And one thing you can do also, you can sort of combine classical like sensor approaches with these learned predictions to sort of create boundaries of safety, which is what I see working quite well.
Biggest problem, 2 levels. On a macro level, manufacturing is really important in the United States. And at the same time, we're not competitive. Like if you quote parts in the United States versus elsewhere, it costs 5 to 10x more to make parts here, which I'm sure everyone here can attest to.
And it's slower.
And it's slower and just not quite as good. So we're not competitive in terms of manufacturing anymore as a country. And robots are really the way to get more competitive. They're the productivity booster, where a worker can do what 3 or 4, like one worker can do what previously took 4 or 5 or 6 workers. And so, and at the same time, our competitors like China are installing 9 times, 10 times as many robots as us per year. So they're both more competitive now, and they're installing more of the thing that makes them more competitive. And so I think that's one macro problem that we have. And on a deployments problem, I find it really interesting that if you look at even the jobs that robots can do the most today in manufacturing or industrial environment, like painting or welding or machine tending, deployment rates are still, they're like low double digits %. And if you really dig into why, you realize it's because it's the risk. Like there are customers, and there are a lot of customers that for these most common use cases, they would have a positive ROI if they automated, but they feel like, I don't really know robotics, or I don't have a robotics guy, or is that going to be too expensive to have a robotics guy join the company? What's that going to cost? Or what if my orders change next month and I have to make something else that's different than what I make today? And is that, I'm going to be able to because the integrator often charges as much as the robot. So you had to call the integrator back and pay that integration fee again. And so this creates risk to that you won't see the ROI you're expecting to see, and so people don't automate. So that's kind of like one problem in terms of deployments. And the other problem I would say is just most jobs can't be automated today. And this is where the big macro trend happening that we haven't talked so much about is physical AI coming to AI coming to the physical world. And you can now train robots just by showing them what to do. And we make devices for that. And there's teleoperation, and there's direct manipulation. But you can show the robot a task, and that's collecting training data to train an AI model. And I'm sure some folks are really attuned to this, but maybe not everybody. And so this is the sea change, where all of a sudden we can now automate jobs we couldn't automate before. And that's the other big problem is no one yet has deployed really easy to platform to train all these jobs that are previously, we call them impossible tasks, because there's too much complexity or variability in the real world. And so that's what we're doing, is creating that platform to train these things. So it's, impossible task, and then it's like just lowering the risk, making the product easy enough to use where people feel like they're going to get the ROI they want to see.
You don't necessarily need to say something, but I would like to pick up something. You were talking about failures. And I mean, this is just part of the progress, right? The robot needs to learn, the software needs to become better. The company needs to become better at handling these kind of things. And as I would like everyone who's listening, and hopefully a lot of founders or potential founders, the situation where you show the customer, and here you don't need to get too much into detail or to be too exposed too much, but I think these are very important like situations, and maybe this can be a bit educational here. So how do you handle a failure if you have a customer, if you have a investor there, and then everyone is trying to do the best, or when there's an exhibition and a demo day before the demo, if there's a failure happen, how do you act? How do you react to this? Maybe you can share some anecdotes that you would like to share.
I can go first. My secret weapon for investor demos is I just continue like there was no failure and they don't notice, and that's my secret. So you don't have 2 million followers on Twitter. So. And I'd say like 99% of the time they don't seem to notice, I don't think, and then they invest. So you just keep going.
I mean, I honestly think about failure rates as just indicative of where the technology is. And I think people who are aware of the maturity of both what you're doing and the field will calibrate, both based on the failures they see with you and knowing kind of the stage of company. Like, I think for robotics, a reasonable metric that people will track is like mean time between failures. And I think when something is a demo and you have one prototype or a small number of prototypes, I think the expectation as you're showing it off is something might go wrong, and you should be able to recover from that by fixing, troubleshooting the situation, and kind of retrying the demo. When something is a product, I think the expectations are very different about that. And so when you're at the point of maturity in your company's lifecycle where you're selling a product to customers, I think if something goes completely wrong that you're presenting as something that is mature about your technology, that's legitimately not good. I think if it's a part of what you're doing that is kind of an optional capability, or it's at the forefront and maybe it's something that you haven't guaranteed is supposed to be provided, then I think that's understood to be more acceptable. So I think it really, I think this is calibrated. I don't think there's like a one-size-fits-all answer to this. I think it depends on kind of the maturity of the product and what you're trying to accomplish.
With us, with Ultra, because we're blurring the line a little bit at times between prototype and production. Like oftentimes we're deploying a new process at a new customer, trying to make our technology work for them. We just bake it into the operating model. It's always a little bit sad to plan for failure, but realistically, autonomy, hardware reliability, those are going to take a long time to get to even 99.9% reliable. And so my view is that getting these systems to work for customers involves building the systems that let you recover gracefully when there are failures. I don't think there's any world where a learned robot model is going to give you more than 1/9 of reliability. It'll be at least 10 years, in my opinion. So we are building our company and our organization with the expectation of failure, and being able to build the organization to keep things working for our customers. Eventually, hopefully, that function disappears because the autonomy does get good, but we're kind of planning for it to take a long time.
As I work mainly with robotics companies and founders in the pre-seed Series A stage, coming back to what you said, Josh, expectation management, if I would like to call it like this, I think you're not necessarily looking for customers and clients, you're looking for partners, because you do need them to bring it to a level where it is a product, right? And so you're coming with 85, 92%. And if you don't have a partnership with a customer, because they're looking for technologies they have no access to, they cannot develop on their own. So they're giving you this kind of trust and backwards. So I think this kind of relationship needs to understand this will take a bit longer than necessary, or that that it is necessary to bring the product to the 99.999% that they are used to, especially like in manufacturing and automotive. If you're talking to BMW, they say, yeah, this is the reliability that we are aiming at, right? And so if you come to the table with a product that is not there, then we're not implementing it. And I think this is something that needs to be articulated and brought into the relationship with a potential customer.
It also probably needs to be said that one of the promises of world models is that typically these failure cases are very, very expensive to simulate. And world models kind of allow you to do this at a fixed cost. So the way to think about this, if you were to do this in a classical simulator, to account for all the ways that people can interact with systems is very, very difficult. But world models just use video to learn these dynamics of unfolding sort of reality. And it actually allows you to simulate a lot more adverse events at a much lower cost. And so my hope is that we bring that time down quite a bit by being able to simulate adverse events, which are actually realistic. What you're doing in a simulator is not very realistic, and accelerate those timelines quite a bit.
Just as a question to follow up on that one, I guess I've heard that as a story, a selling point for world models, that you could do corner case evaluation and situational testing. I would imagine that in most data sets that you're training these world models on, the kinds of corner cases are themselves rare. And so I always do kind of wonder how likely you are to actually have good coverage of all of the hard cases and have that coverage produce reliable enough simulation for the world model to be able to produce things that are realistic and diverse.
Yes, I think in our case, we see about 1 billion video uploads a year, and you'd be shocked the amount of crazy adverse events are in there. As to the question, I think the claim is not, oh, this is going to get you there. And the way we test this technically is you go capability by capability, right? And so you basically test which capabilities can you train on large pre-trained models, which are either trained in games or simulation. How much real-world data do you need to add to that in order to avoid certain real-world scenarios? And we test those curves. And you start with very simple use cases like navigation, and you look at the curve there, and then you go into increasingly complex use cases. So far we've seen it work for navigation. I imagine as you go into fine manipulation and higher dexterity, it gets more complicated, and the problem space blows up. So I think, however, I think because it gets more complicated, right? To infer those things from video is nearly impossible. And so you're going to need to solve a bunch more problems in simulation for that, I think. But I think a lot of these problems are solvable, and it gets you to a much shorter timeline than if you couldn't simulate these things today.
To quickly talk about the importance of design partners at Ultra, I want to shout out to our original design partner, Richard Hurley at Highline Commerce. I don't know where you are, but I hope you watch this video. Richard, we met him right after we got into YC. And he has let us build 3 generations of robot in his warehouse, alongside him, alongside his team. And again, just the difference of rolling these robots across the street. John, who I'm standing in for today, likes to talk about kind of these like big milestones in literally where physically your robot is. So robot in the lab is like the easiest possible deployment. Robot across the street is suddenly 10 times harder. There are all these new problems you have to figure out. There are people poking the robot, but you can still walk over and fix it. Then you send it out of state. And then suddenly you have to get on a plane every time you see these robots. And so the value of having a design partner is, for us, it got us out of the lab and made us feel even more comfortable when it came time to pack a robot onto a truck and send it places like Texas or Chicago. You learn a lot in doing it, and it makes you a lot more confident when it comes time to send them to crazy places. Not that Texas is crazy.
We were talking about costs, Pim, and you came to this as well, like how expensive it is to every time go on a plane and go somewhere. I think each and every one of you have plenty of examples, but maybe you can think of something high level. As we are talking today about prototype to production, what are the expensive lessons that you could have anticipated in the lab? Something that you needed to learn. You were giving the example earlier, but this was a very specific example, right? Something that you couldn't think of because you don't know the use case because you're not in logistics. But generally speaking, for robotics companies, a lesson that needed to be learned the hard way when it comes to moving out the robot from a lab to the customer.
Really quick one. We deployed our first systems without KVMs, and so we were leaning on our customer a lot to do some specific resets. Now every robot we ship out has a KVM attached. Just very basic thing that we didn't think of until we were trying to restart the computer and couldn't.
That's great news. Thank you.
I mean, one that's also kind of a lesson is that batteries are hard to ship. You can't take them on a plane in most cases. So like when we've traveled with our robots, we can fit the robots on the plane, like, which is to say our robots and the packaging weighs enough that we can just check it as a normal bag, which is cool.
That's really awesome.
That's convenient, yeah. But we have to mail the batteries and then pick them up somewhere in order to have them.
So in our case, it's latency. This is a customer in simulation I'm referencing. All of a sudden, when you ship it to customers who run it on different clouds, they have workloads with wildly different latency distributions than you have maybe on your evaluations, for example. We found a fun example where, because in the gaming client, the latency to game servers is actually fairly randomly distributed, there is a scaling law associated with that. Actually, as you train more, the model can handle latency more and more. And so we were able to move the window of prediction out from maybe like 30 milliseconds to 50 milliseconds to 100 milliseconds, which made cloud inference reasonably possible for this particular use case. So it's quite interesting. For us, latency is probably the hardest one because these are models that run on the edge usually, and you need, sometimes you need to distill them for local use. But really, the latency environment for us was the hardest one to get over.
Just quickly, one of the things we had was a customer that had an acidic compound in a machine they were loading and unloading, and we kind of designed our seals to work for most coolants and those kind of things. But this is a very special product they're making, and so it actually like melt the rubber-like material that seals the joints, and so they're like. It breached the IP rating, and we had to we replaced it, and then it happened again, and we're like, so then we looked up the MSDS of what they're using, and it's like totally just melts like any robot. So some things like that have been fun to learn.
You were talking about latency. Not everyone has something to say to this topic, but as we're talking about prototype to production, Teleop is a big topic, right? It's very normal. I think during that demo time in the last 2 years, some people were trying to hide it because it's not autonomous. It's not autonomy, but this is just part of the progress, right? And but as we go further in the journey, and as we're talking about deployments, so for robot companies who do use AI here, maybe you have a take on that. The challenges that you guys see, and especially as we have part of the robotics community here, maybe later on in the Q&A, some people can ask some questions here. But I would like to get a good understanding of the progress that you have seen in the last 2 years. Maybe you can give us your opinion about this.
Ultra's relationship with autonomy is.
Relationship,
it's complicated. At customer sites, we teleoperate our robots primarily, and that's to ensure the quality of the work that we're doing for our customers. With our previous generation of robot, we did get to pretty high levels of autonomy. The challenge that we ran into, though, is making sure that the work that the robot thinks it's doing is actually the work that's happening. So it's a bit of an open problem for us, but one that we're thinking about. We at Ultra are not directly investing in autonomy. We have a great partner, Physical Intelligence, who's training quite a bit of models, all kinds of mixes of our data and theirs, different different model builds. We've been working with them for over a year now. So our strategy for autonomy is likely to outsource it and hope that just having the most robots ends up being the contribution that we can make.
The thing that we've run into is it's just a really hard problem to make it super simple for an average person to train a model and deploy it. And our target user is not a software engineer. It's an assembly worker who might be loading and unloading a machine or just working in the factory normally. So how do you create an interface where someone who isn't a software engineer or doesn't know much about AI or anything like that, it's simple enough where they can demonstrate their task and collect their data and curate it and train a model and deploy that model. And if it's making a mistake, like retrain it. And so that has been a big challenge and has taken a lot of iteration to like try to get the user interface right and try to figure out what are the right parameters to expose and what can we set automatically. And so that's been one of the challenges. And of course, there's we have our foundation model behind it where we collect a lot of data from a lot of different customers and train the model so that it can perform unseen jobs as well as possible. And so we're spending a lot of time working on that as well.
Yeah, for us, I think we see it as part of the solution. So we have about 15 million gamers that have game controllers that are distributed all over the world that we plan on actually using on just making teleoperations part of the offering if you're using the models, because there will always be edge cases. And I think and you can just use the same API. And for us, I think the other thing that's interesting is it's not a binary teleop or no teleop. In some cases, like the drone delivery services, they use, it's about the number of concurrent drones, for instance, that one human can manage or observe. So it's really just about understanding the customer problems, and it's something as simple as being able to predict an adverse event with slightly more precision means that you can scale from 1 to 1 human to drone to 1 human per 2 drones, 4 drones, etc. And so it's more of a sliding scale than a binary problem, in my opinion. And every customer will have just slightly different requirements for this.
For us, I mean, I think we're definitely aspiring towards autonomous robots operating in human spaces. The first product that we've shipped so far is a dev kit. So we provide what we think of as services that people can build on to experiment with more local autonomy, right? They can try things. We're not expecting it to run indefinitely with perfection. We're expecting people to leverage the core services for mapping and navigation and social interaction and things like that. I think the other side of it is a lot of where we've been trying to push on autonomy has been on the human-robot interaction angle. So like having a conversation with the robot, being able to give voice commands and then have the robot call its tools, kind of like an LLM agent, and perform simpler tasks where the level of reliability is tractable for the current technology. And I think over time, our mentality has been to start with use cases that we think the technology is tractable today for or are on the cusp, and kind of as models develop, more and more will be able to be automated.
I remember how happy I was when you guys said yes to this event and everyone else contributing to make this happen. I know that it's not too often that you have the opportunity to have so many great people from so many great companies right in one room. So I do know that we're coming towards an end, and I would like you guys to give the opportunity to ask questions. Every now and then I have a very quiet audience and a very shy audience, but I heard that people from New York are not belonging to this category. And so I hope we can have a Q&A where you guys are able to address some people. Keep the questions short and the answers as well, so we can cover a few. Yeah.
Yeah, I'm allowed New Yorkers.
Yeah, you are.
Josh, and if you can't say anything, get it, but you mentioned voice, and your acquirer has big voice position in the marketplace. Can you speak about what to expect now that Amazon is involved in Fauna?
Yeah, I mean, I won't go into like too many specific plans, but I would just say we are continuing to operate as Fauna Robotics. We're trying to pursue the same vision we had as a startup, which is to be shipping robots and getting robots kind of everywhere that people are I mean, I think it's natural to speculate on lots of different things. I think it's also the early days. We've been part of Amazon only for about 2 months, and so again, a lot of what we're trying to do is keep up the velocity and continue to push the bounds of what we can do as Fauna Robotics.
Oh yeah, my question wasn't targeted towards anybody specifically. Whoever wants to answer it can. But I was going to ask if you guys think that action policies need explicit dynamic models, and if so, in the pixel space or latent space.
Latent.
Yes, I wanted to understand the connection between deployment and simulation. You know, you're generating terabytes of simulated data, vision and touch and all kinds of things. Then you have a failure in the field. How do you map the failure back to your simulated data so you can try and get some root cause understanding of what happened?
My maybe controversial take is we try to use simulation quite a bit, but the reality is simulators today, even the best ones, are very poor at representing the real world. And they're great for reinforcement learning, right? If you want to make a humanoid flip or break dance or whatever. But I think for actual things our customers want, turns out you can't do RL like that. And often there's some part of the task that's just really hard to simulate. Like they want to cut something, and it turns out you can't cut meshes in most simulators, or it's hard to simulate the friction or suction, or there's almost always something where it's like we'd be having to rewrite part of the simulator. So we just don't do a lot in simulation for that reason, for our policies.
Pim, do you have an opinion on that?
Our customers right now are using cloud inference for the most part, so it's slightly easier, which is we just clip it, and we learn from the stream. So I have it much easier than these guys in that sense. These are vision-based models, so in our case, we collect the data as the failures are unfolding, and then we collect it later and feed it into the evaluations for the policy. You can basically see if the policy would. You can use that as an evaluation case to see if the policy would, as you improve it, predict the same set of sequences the next time around. And you can simulate variation. Using world models, you could, for instance, simulate variations of that failure, so it's very valuable using the same clip, and see whether the policy in different variations of that failure makes the same mistakes. As long as, in this case, you would stay in pixel space.
I'll give a quick hedged answer, which is that whether you're dealing with real-world data or simulated data, when you see failures, you do need to cover those holes in your model, right? Like you need to figure out where the gap is and why it's not performing that way that it should, and then you need to collect more data if it's real-world data, or you need to generate that data synthetically. And either way, you still have to figure out kind of the root cause.
Hey, thanks for the time. Maybe a question for Oliver and Evan. When you think about the processes that you essentially are going to automate, how do you balance what the customer wants and customizing sort of every deployment versus, hey, these are the 2, 3, 4 that we offer as a menu and you take it or leave it? Because I guess just to follow up to that is, you both mentioned that ROI around labor takes a while. We all know that once you deploy, it's probably going to be slow at first. And so maybe there's like a yield fallout angle here. But yeah, curious how you're thinking about the processes that you go after.
We have tried to make like Legos of robotics, so we can give customers single arm or 2 arms, and it's not an engineering project. It's kind of, you can snap it together and send them the right things. And we have a apps engineer talk to the customer, when they're buying if needed, and they'll say, okay, you should use this base and this gripper and this, and help them get the configuration right. And then we just mail it, and then they're kind of they're able to set it up. I think that's been the best approach for us.
Ultra's approach here, this is why we're going task specific to start. So even though there's a lot of variation within that task, different warehouse management systems, are you putting the shipping label on before or after you pack the item? Are you weighing it? There's all these little things. It's still a much smaller problem space than we would get if we were trying to do a general purpose kind of do anything robot. So, the expectation is as we deploy more and more of these systems to more and more warehouses, our matrix of like supported combinations of things will get much bigger. And, hopefully in 6 months or by the end of the year or so, we will have a lot more of those drop-in deployments where we already work with Ship Hero and you're using a flow that we are very comfortable with and stuff like that. So again, like less focused on selling you a robot to automate a task and much more focused on selling you a solution to a specific work stream in your warehouse.
Just one. I'm not one of these, but I work a lot with robotic startups, and so they are having the same kind of question: what we are focusing on. And I think it's very good if you're looking at what are the capabilities of what can your robot actually do today, and then you talk to the potential customers because there's a lot of I would like to have, and then I'm willing to pay for. And then I think also is that a strategic decision will not work today, and there's no volume behind that, but this will unlock a lot of other potential bigger partners. So I think here, if you're looking at that, what is the volume of it? Is that a strategic or volume decision? And what can the robot do today versus I'm talking some vision topics. Like this is the vision, what we can do in 2 or 3, 4 years. I think you are much closer to reality if you stick to those questions. We have another question over there, I guess.
My question is, when going from pilot to production, you talked about the expensive mistakes that you've made, but are there any manufacturing specific mistakes that you made or lessons you learned that you wish you had known earlier or that somebody had told you earlier?
I can take this one. So we're doing we make our own circuit boards, we make our own encoders, we make our own. We're moving to make all our own metal parts, including casting, later this year. So pretty manufacturing intensive. We have 70,000 square feet right outside the city. We've learned a ton of stuff. So we kind of started by trying to find someone who helped build an auto plant from scratch, and they were kind of our mentor. And they're like, all right, they just got like lessons, and every night I did like 4 hours with this person, and they had started. For one of the big autos, like literally from scratch, they created an entire plant, and so they were just like training us every night. Like, all right, here's it kind of felt like going to class, and they'd ask questions, and so that's how we got started. But I learned so many things, and I really think the manufacturing of the product is a product in and of itself, and so we've never handed it off because we know that. And we have software for this, by the way. So as you're building our robots, the assembly operator has software where it guides them through each step, and they can test at each step and improve. But as you're building the robots, you're like, if there's ever a problem in the field, we tie that back to, okay, who did it? How long did it take? What were the quality steps followed? And we record a record of all that. And so it's a product in and of itself to make the product that we're constantly improving. And so I think probably the mistake we made initially was not thinking of it that way, but that's how I think of it now. And you got to constantly, just like for your product, you're constantly iterating and improving, and we're creating getting more efficiency and getting problems out, and you learn things even still every month in ways we can improve and be more efficient.
Thank you guys for the time. As you were describing deployments and the challenge, part of the work has been to make the integration more generalizable and faster and easier for Bob, the line leader, to install the robots on their shop floor. Is there a future where system integrators don't have a space to play in terms of bringing robots to the manufacturing shop floor? Or do you believe really what we're trying to do is make it as easy as possible for the shop floor operators themselves to install the robot?
Yeah, I kind of think it's both. And I think we're going to need, I failed to mention the other answer. We have 26 integrator partners that we work with. And if in a world where we're installing millions and millions and millions of robots, I think we need actually a lot more integrators, but there's also going to be a lot of robots installed without integrators. So if someone needs miles of conveyor belts, you're probably going to need an integrator to come and do that. So there are classes of job or task or installation where you need you're going to want specialists. I mean, what is an integrator at the end of the day? It's talented people who know about, maybe whether it's feeder bowls or conveyor belts or what have you. So there will absolutely be a world for that. And we're going to need a lot of those specialists for lots of these jobs like that. And I give more examples, but the conveyor belt thing is one of the more common ones. But a lot of people, these products should be like consumer products where you can just pick them up and understand them and install them. And so what integrators do today, which is product is so confusing. And if you look at the top robot companies in the world, like they'll have menus where it's a single letter. It'll be like R, L, J, and you got to like look in a manual to know what it means. It's kind of, it blew my mind the first time I saw it because I don't use any other product like that in my whole life. And I couldn't believe because their marketing looks amazing. And I thought a product would be, we bought our competitor and it's like, it took 8 hours to get it to move. And I'm like, holy shit. It came with wires just sticking out. Like there's no plug on it. I'm like, holy shit, I've never bought a product without a plug on it. So this is the bar. And so what integrators do today is they put the plug on and then they you actually like put a wire and short 2 terminals out to even get it to move. And they're doing these kind of things that you to go to a course to figure out how to do. So that's going to go away 100%, but I think you're still going to need a specialist that knows how to build, often your manufacturing facility is like this organism. It's like part of your product, and we're going to need specialists, a lot more of them to help create, more manufacturing facilities as we bring more manufacturing back.
From the research side, you do see that you need also less customer-specific data as you scale environment diversity and data scale. But I think that one of the best things about automating things like production is that actually one of those things that helps too is build more robots. And so I think you kind of get this underlying, if we get things right, you get this underlying supply curve that hopefully gets unblocked, which means, maybe per integration task is slightly less time because the models are more general, but it likely also means the number of combinations of type of systems that you can build and integrate goes up. So I think they grow hand in hand, if not much faster on the integration side.
Thanks so much, gents. So my startup is in the egocentric and tactile collection business. And specifically, we are collecting in care environments, so hospitals, nursing schools, et cetera. What we are finding is that there's a certain amount of market making that needs to happen. There is no real precedent for the kind of data we're trying to put out. And so I guess I would love your advice on how, if we're coming at folks with something where the people that we're talking to have either a lot of digging as middlemen to do that you have to incentivize them to do to seek out your data and engage with it, or try to become friendly with the frontier labs. Is there a way that you think about the kind of data you're looking at, or what trends you see in the stuff that is getting popular?
I think the most valuable thing you could do is train a useful model with your data to prove that the data is good. The nightmare case for your company is that somebody buys it and then you realize that it's no good for some reason. So that would be my recommendation is make sure you can train a model and then try to sell it over that way.
I agree. The best way to learn your own data is to build basic models with it. Like you'll learn many things, like whether or not you're sequencing frames and actions correctly, and all these like small things that if you don't do that, you reduce the causal structure in the data, and so you learn all these little things when you start modeling your own data. That's how we started too, before we started the lab, we always look for customers and providers that have unique sets of data. So happy to have a conversation, and we're also very open about helping you guys figure that stuff out.
I would say we get approached by 2 people that collect data every week. So there's so many. So I would say don't do that. What I would say do instead though is I think if you can vertically integrate and build a solution in, like if you're collecting data in hospitals and nursing homes, like build a full solution that does something useful, like beyond just training the model, like get the robot and figure out what end effector you need, and you know what I mean, like something that you can actually sell. Like, and I think that's what we've done from the beginning. And I think I've seen a couple cohorts of robotics companies kind of come and go as we've been going along. And I think it's so important that you can build something and sell it today, and it has a lot of value today to whoever you're selling it to. And if you can go and automate something in a medical environment, I mean, there's, just talking to Mayo Clinic, there's so many tasks that can be automated in those environments. If you can create the full solution that you can sell that can then solve the problem, like you could sell a ton of those right now, versus you're trying to sell someone on, hey, buy my data and then you build the solution to go sell, right? Because like ultimately it has to connect to adding value to that end customer. And if you're waiting for someone else to make those connections, like you're just kind of waiting until there's enough other people to make that connection all the way through to the final sale. And like maybe you sell to a lab, but are they going to buy next month? Well,
I'll add, so labs do tend to need less data for every piece of data that they get. which is why we are launching a fine-tuning environment where you can actually just keep your data and we have very general models. You can just fine-tune with it, keep it, so you can still come talk to us. Yeah, I think we started like this, and the answer is get to know your data better than anyone, and then figure it out.
Josh, final word on it?
I do think there are a lot of startups trying to sell people data. I get pitched on it like extremely frequently. I think I think the reality is it's tough in part because I think people who are trying to sell people data are overly optimistic about how useful that data is for everyone's robot application. And I also think it ends up basically being just a race to the bottom in terms of who can collect the data the cheapest.
Thank you all. This was a great conversation.